Okay, this is the robot. The gripper unit is over there on the left, and it's attached to the arm, the vertical arm, and it goes quite high up there. And then it comes down and attaches to the base, located here. And the base has got some wheels, of course. And then the brains of the base is all located on the back of the unit. We'll talk a little bit more about that momentarily. Let me relocate the camera. Okay. Now, the navigation camera is a little web camera that's bolted onto the top of that aluminum plate over there on the upper right. It's not very big. The thing on the left is actually just used for debugging. It's a little laser pointer that I can shine a light up on the ceiling. It sort of tells me how well positioned everything is. I really don't use the laser anymore. The black box under that is the brain of the robot. It's something called an I-Omega iConnect. I don't think you can buy them anymore. But basically what it is we're running Linux on it, and it provides us a Linux operating system with a complete internet stack. It's got a Wi-Fi built into it so that it provides Wi-Fi connectivity. And then it's got 4 USB ports that I can plug things into. And in particular, the navigation camera is plugged into this as well. And then it uses a little serial connector to serial cable to control the rest of the robot. The navigation camera images are read from the camera, loaded into the computer over USB, and then we do all the image processing on the in the iConnect and figure out where everything is. The navigation camera is in the back of the robot, and that means that because the vertical arm is in front of it, we cannot see fiducials directly in front of the robot. It doesn't matter. We can work just fine with fiducials that are in back of the robot when it comes to navigation. But it's kind of peculiar. The robot can see fiducials to the sides and in back, but not in front. Doesn't matter. They're markers, and we can navigate from basically the markers anywhere that they're visible. So I just wanted you to know that little important little feature about the navigation. And future robots will probably wind up having multiple cameras on the robot so that we don't have blind spots like this. But for now, it doesn't matter. It works just fine in back. Okay, that's about it for discussing the navigation camera. Okay, this is the robot, and it's stationary. And if you look up on the ceiling, you'll see that there are fiducials, sometimes called tags, and these provide basically landmarks for the robot to navigate against. There are other ways of doing the navigation, but this is one of the least expensive ways. So, next we'll show you the user interface over there on the computer and show you how this all works. Okay, this is the GUI. If I had 2 cameras and much more skill with video editing, I would be attempting to do this demo with the GUI split screen with the robot in movement. I don't have that ability, so what we'll do is I'll show you the GUI first, and then I'll show you the robot moving in under the control of the GUI. To start this all off, we fire up the robot, which you can't see me doing off screen here. And then we turn on the navigation camera, and what you see is these little green squares which represent fiducial markers that are on the ceiling, and we picked up two of them immediately. This one is in the lower left, and this one is measured in relationship to that one. This is the robot. It consists of the inner arrow thing, which points in the direction of the robot, and that's where the camera thinks the robot is. And then we have the outer outline, which is where the dead reckoning system believes that the robot is. Due to motion blur, sometimes the camera can't see the fiducials because they're all blurry, and you'll see the outline getting ahead of the robot. In addition, the color changes depending upon which fiducial the camera is using as its reference point. So sometimes you'll see the robot jumping around a little on the screen because it's changing from fiducials, and you can tell that by color changes. So I can physically go over here to the robot and move it by hand, and as it's moving, you see a sort of set of breadcrumbs going behind it, and what you saw there is it picked up the next fiducial automatically. As soon as it sees a new fiducial, it picks it up and throws it on the screen in relationship to the others. As you saw, the robot didn't see it until it went past it because the camera is mounted in back of the arm. So it couldn't see in front, it can only see in back. The robot can do just fine with markers in behind, but it's a little confusing at times. Now, moving over to this, you also saw that the color changed. So now what we want to do is like, rather than me physically push the robot around, we can do it under its own power. So I go into this mode, which is go-to mode, and then I can just click on the cursor there, and it will ride over towards whatever point on the screen I do. So I can drive it all over the place here. You should be able to hear the robot making noises there. And it picked up the next fiducial here. Let's drive it a little further. You see the dead reckoning got ahead, and now we picked up another one. Again, the color changed. It's using a different marker to show how things are going. Let's move over here. Okay, again the color changed, and we picked up another marker. Okay, and we can just take it over here if we want. Okay, so that's the auto mapping. That's the path of the robot. I can clear that path, and then I can save this map of the fiducials, and now we can go to the next phase of all of this. Okay, the next phase is we can start drawing waypoints on this map to indicate where locations that we would like the robot to go. The whole concept behind the waypoint is that humans tend to make pathways through their environment, and so what we want to do is put waypoints where basically human paths are. So let's start first by marking a point and creating a waypoint. The little waypoints are little red squares, and we'll create another one, and say another one right there, and maybe another one over here. I want another one there, and what the heck, put one there. So now what we can do is we can connect these with a path, which is just as simple as clicking on the mouse like that. So now this is a path that the robot is programmed to take through our space. Okay, we can save this. So we've saved both the map and the waypoints, and now the robot's ready to go driving along one of these paths. So let's select the point here, and let's go click Way Go To, and the robot will find the closest point to the path, turn to that, and then it will just go to the next point, and we'll probably see the dead reckoning system getting ahead of this at some point. Yeah, maybe not. Yeah, there we go. It's got ahead. But then it just dead reckons to that point, and away we go. So if I want to go to this point, I just click on it, go away, go to. We turn to it. And just to sort of, finish making the point, let's go all the way back over here and go there. Oops, ran into something. Oh, so sorry about that. So that's basically the GUI and all this stuff. We can clear that to get rid of all the clutter on the path. And that's all there is to it. So now I'm going to go shut this down and show you the robot moving along this kind of a path. One moment. Okay, I've relocated the camera tripod now, and all I'm going to do now is go back to the user interface, click the Away Go To button, and then I'll track the robot as it moves. So now it's just turning around. And then we go to the last waypoint. And then we stop. And that's basically how it works. Not much to it, really. So that's how the whole auto mapping and path mapping stuff all works. Thank you very much.